All right, so we are going to look at chapter 10 and 11 this week. We only do 2 sections in chapter 10, and we're only doing 1 section in chapter 11. Chapter 10, part of it is on solving systems of equations. So we're going to look at, first we're going to solve 2 variable systems. So that means each answer is going to have 2 numbers to it. And then we're going to look at solving 3 variable. Just a reminder of what a system is. Okay, system just means you're solving for more than 1 variable. So it's equations that have more than 1 letter. Systems can have as many letters as you want. You could have an equation with 5 variables in it. We don't do any with that many, but we will do 2 variable and 3 variable. There's different methods that we'll talk about. Substitution, elimination, and matrix. Okay, so substitution and elimination are generally what we're going to use for 2 variable. When we get to a 3 variable, we can kind of do elimination with it, but a matrix is a more efficient way to do it with less writing. So we'll talk about a matrix tomorrow. Yes?
Are we going to do matrices in this class?
Only with regards to solving systems of equations.
Okay.
Yeah, there's tons of things you can do with a matrix. A matrix is just a way to represent numbers. It's just a table.
Yeah, we did a lot in discrete last year.
Yeah, you can do a lot of different things with matrices. We're just using it to organize numbers. That's all. All right, so the first one, they just want us to set it up. We're going to solve it in the next problem. Okay, but for now, we'll just set it up. They want us to find the length and the width, so it's a 2 variable problem, of a rectangle where the perimeter is 100 and the area is 300. So this is a 2 variable problem. It relates to geometry. You would need to know the formulas for perimeter and area of a rectangle. Okay. If it was a shape that wasn't common, I would give you the formula. But rectangle is common enough, you need to know the formula. What's the formula for area of a rectangle?
Length times width.
Length times width. And what's the formula to find the perimeter of a rectangle?
2L plus 2W.
2L plus 2W. Okay, so those you would need to know. Now we're going to fill in what they give us to write our equations. For area equals length times width, what do they tell me the area is?
300.
300. So we're going to fill 300 in for A. Now, if that's the only piece of information I gave you, that's not enough information to get a unique answer. Any numbers that multiply to give you 300 could be the answer to that part. 10 times 30, 150 times 2, 75 times 4. Right? There's lots of things that multiply to give you 300. But the perimeter also has to be 100. That's going to narrow it down. So fill in 100 for perimeter. And that is the setup for our 2 equations. A lot of times when we are solving equations, we're going to use x and y. So I might change that to an x and a y when we solve it. But if you want to use L and W, that's okay too. That makes more sense for length and width. Any questions on how we set those up? All right. Now, the way that you would want to try to solve that problem is with substitution. Elimination would not be a good way to solve that. When you use elimination, you want your equations to look the same. Like you have x's in a column, y's in a column, and then numbers in a column. In this one, we don't really have that. Okay? If you were going to use elimination, you'd want L's by themselves, then W's by themselves, and then numbers by themselves. We don't have L's and W's by themselves in the top equation. We have a product of L and W. And you don't have that in the bottom. So because these equations have different look to them, elimination is not what you would want to use. So we're going to use substitution. Okay, so there are three main steps when you are using substitution. Okay, the first step is you have to pick an equation, and then once you pick an equation, pick a letter to get by itself. So you have 4 options for step 1. You can either choose equation 1 or you can choose equation 2. If you choose equation 1, you could try to get x alone. If you choose equation 1, you could get y alone. There's 2 choices. If you pick equation 2, you could get x alone. Or if you pick 2, you could get y alone. There's 2 more choices. So you generally have a total of 4 different paths you could follow. When you start to get into 3 variables, you have a lot more paths. That's why substitution, sometimes it just gets a little overwhelming to do that with 3 variable systems. And generally we won't. We're going to use elimination. All right, so first pick an equation, pick a variable to get by itself. Second step, once you have a variable by itself, you're going to have a formula, and you're going to plug that into the other equation, the equation you did not choose in step 1. Okay, when you finish step 2, if you've done it correctly, you will now know the answer to one of your letters. Once you have the answer to one of your letters, you're going to take that answer and you're going to plug it back into one of your original equations. That will give you your other answer. If you've solved correctly, it doesn't matter which, once you get your answer from step 2, it doesn't matter which one you plug back into. I would plug into whichever equation you think is simpler. But that's the general steps anytime you're solving a 2-variable problem. So we're going to try those steps on the equations we just made, but I'm going to change the x, I'm going to change the L and the W to an x and a y. Just because I want you to get used to solving it when you see x and y. All right, so first step, we're going to pick an equation and we're going to try to get a letter by itself. Which equation do you think is simpler to work with? Equation 1 or 2? 2. Yeah. You can get a variable by itself in equation 2 in one step. In equation 1, you cannot. So we're going to work with equation 2. What letter are we going to try to get by itself in equation 2? Yep, sure. Let's get x by itself. So to get x by itself, what would I have to do on each side?
Divide by y.
Divide by y. So x would be 300 divided by y. Any questions how we got x by itself? So now, once I know y, I'm going to fill it back in right there. 300 divided by y will give me the answer to x. But I have to figure out y first. What are we going to do now with that 300 divided by y?
Plug it in for x.
Plug it in for x in which equation?
The first one.
The first one. So you're going to take that and you're going to fill it in right there. So we've got 2y plus, and now instead of writing x, you're going to put 300 divided by y. And you can write it just like that. That's fine. It's 2 times 300 over y. Okay, so let's simplify that a little bit. 2 times 300 gives me
600.
600. generally, if your equation has a fraction in it, the next step is to get rid of it. What could I do? I'd have to do it to all three terms to get rid of having a divide by y.
Multiply by y.
Yep, I can multiply everything by y times y, y, and y. You don't always have to multiply everything by a variable. I'm doing it because we had a fraction with a letter in the bottom. Okay, what's 2y times y? 2y squared. And what about 600 divided by y times y?
600.
Just 600. And on the right-hand side?
100y.
100y. Now, that's not written in the order we normally see it, but what kind of equation is that? What is it?
Quadratic.
Yeah, that's a quadratic equation. So generally, when we are solving a quadratic, what do we try to get it equal to? Get it equal to 0. How would you get that equal to 0? Yep, and that term would go in the middle. So 2y squared minus 100y plus 600. So that's a quadratic, and that's the order we normally put it. What's one way you can solve a quadratic equation? You can use the quadratic formula. What's another way you can solve if the numbers are nice? Yeah,
Factor.
you could factor. Regardless of which method you want to try, factoring or quadratic formula, there is something I would do first. It would at least make the numbers a little easier to work with. Yeah?
Simplify them.
Okay, what could we do to simplify that a little bit?
Divide everything by 100.
Well, you can technically divide by whatever you want, but I'd like to avoid turning things back into decimals or
Divide
fractions.
everything by 2.
Yeah, if we divide everything by 2, we will not have any decimals or fractions.
2 examples.
So again, could you technically divide by 100? Yes, but then this number would have turned into
A fraction.
a fraction. So that's the equation we want to work with, and I will tell you it is not factorable. So we're going to have to use quadratic equation. All right, so first thing we need to do, when you're using quadratic, identify the three numbers you're going to plug in. What's A? 1. B?
-50.
And C?
300.
300. And if I start doing my quadratic formula, anybody tell me what does it look like when I start out?
Opposite B.
Opposite of B, okay.
Plus or minus square root of negative 50 squared.
Yep. And what's negative 50 squared?
2,500.
2,500. So negative B plus or minus square root of B squared
Plus 4.
-4.
minus
4 times A times C.
4 times A times C.
Which is 1,200.
Yep, so we'll do minus 1,200 in a second.
All over 2.
All over 2 times A, which is 2 times 1. Okay. So we get 50 plus or minus, that's 2,500 minus 1,200.
$1,300.
1,300 divided by 2. So that is the exact answer, but let's do it as a decimal. Okay, so we've got 50 plus the square root, plus the square root of 1,300. That's the numerator. And then divide by 2. I get 43.03. Now, How many answers, when you're solving a quadratic, you always get how many answers?
Two.
2. That's the first one. And remember what letter you're solving for?
Y.
Y. So that's the first one. I think it was, what did I say? 43 point, let's go 3 decimal places. 028. Or 03, just makes it a little more accurate. Okay, so there's Y1. And what's going to be the difference when I get Y2?
A negative.
Yeah, I'm just going to do 50 minus the square root of 1300 and divide that by 2. 6.972. Okay. So remember, we are solving a system. Are we done? No. In terms of the work, we're like 80% of the way done, but we still have to find what letter? X. And there's going to be 2 answers for it. The only reason this is a 2-answer problem is because it was quadratic. If it's not quadratic, just linear, you don't have to worry about 2 sets of, like with 2 numbers each. It might just be 1 set of numbers, just 1 X and 1 Y. All right, so I've got my Y's. As I said earlier, take each Y and fill them back in right there, and that'll give you the X. 300 divided by Y equals X. That's the easiest way to find it. So let's see what happens. Take 300 and divide by Y. I get 6.972. And now do it again. Take 300 and divide by Y, 6.972. And I get 43 point, well, because of rounding, it's 0.29. But if it was exact, it would have been 0.28. Just going to put in parentheses, if you had done it exact, it would have been 0.028. What do you notice? Think about this in terms of being the length and the width of a rectangle. What do you know? What's the difference between the 2 answers? Just rotated, right? So if this was length and width, your first rectangle looks like that, and your second one looks like that. But they're rotations of each other. Okay. Any question on how we got our 4 answers in that problem? You're always going to have a pair, but in this case you had 2 pair of answers. And what made it so we had 2 pairs instead of just 1 pair? Because it was a quadratic. That's the only reason. Yep. Okay, let's try one that is not quadratic. So this time there will be 1 pair of answers. What equation would be the easiest one to work with here? Yeah. This is when you could do elimination. We haven't done elimination yet, so we're going to do substitution. But we are going to work with the first one. And what letter do we want to get by itself? Yeah. If you can, look for a letter that has a 1 in front of it. That's the one you want to get by itself. Okay. So if we solve this top equation for Y, can anybody tell me? It doesn't have to be in a certain order. However you get Y by itself is fine.
5 minus 2.
Yep, 5 minus 2x. If we were thinking of graphing this, then we would want y equals mx plus b. But we're not graphing. So we got y by itself at the top. What are we going to do with the 5 minus 2x?
Plug it in for the y in the second equation.
Plug it in for the y in the second. Yep. And anytime you plug something in, especially if there's a number in front, it is a distributive property. So make sure you keep that 2 outside of a set of parentheses. Just like that. So 3x plus 2, and then fill in for y, 5 minus 2x. Once you do your substitution, you should not have different letters in the equation. If you do, you didn't do it right. Okay, you should only have the same letter now. All right, now we solve it. What's my first step to solve it?
Distribute.
Okay, so we can distribute, and what do you get when you do that?
10 minus 4x.
10 minus 4x. All right, next step.
Combine like terms.
Yep, we've got some like terms on the left. What do you get when you combine them?
Negative x.
Negative x. Okay, second to last step. Subtract your 10. And last step.
Divide both by -1 or multiply.
Yep, divide or multiply both sides by -1.
Both sides.
And
X equals 8.
x equals 8. There you go. And that is the only answer for x. This was not a quadratic. There's no second answer. Any question on how we got x? Okay, so there's no second answer for x. But what do we still have to find? Yeah, we still have to find y. So take x, fill it back in, and we're going to get y equals 5 minus 2 times 8. So what's 2 times 8 gives me 16. And 5 minus 16 is negative 11. So when you write your answer, you can either write, like I did right there, or if you want to write it as a coordinate, you could do -8, 8, comma, -11. If you were to draw this, that is the coordinate where these two lines cross.
Will we be drawing it this week?
No.
But will you accept both of those on the test?
Either answer? I would accept either one if it didn't say how to write it, but I'm probably going to do something like this on the test.
Okay.
2 boxes. Yeah. Yeah. Okay. Any question on that one? Okay, so that's elimination. Okay, so again, probably something you've seen before. I mean, that's substitution. Now we're going to do elimination. So both of these I think you've seen before. Elimination is how we're going to handle all equations that have more than 2 variables. Okay, substitution's okay if you have 2. But if you start to get into like 3, 4 variables, substitution, it gets really messy really quick. All right. Elimination is much better. And the goal is to basically add one equation to another equation, or a multiple of one equation to another equation to make something cancel. That's what a linear combination is. It's a multiple of an equation. So if this is an equation, here's a linear combination of it. Specifically, it's the linear combination you get by doubling everything. Okay? So the way we're going to do it is we're going to try to get the coefficients of one of the variables to be opposites. Technically, they can be the opposite and you add, or if they were the same, you could subtract. But we're just going to make them opposites. So an example of something that we would be trying to do, 2x plus 3y equals 10. 7x minus 3y equals 5. That would be a goal we're trying to get to when we do elimination. Positive 3y, negative 3y. When you add them up, they cancel out. Okay, but that's the goal. You're going to have to figure out how to make the numbers opposites. And you can do it with the x's or the y's. Doesn't say which variable you have to use. And that's getting at the idea of the linear combinations. You may have to multiply an equation by a number first to make it work. So this is one, when I look at it, I probably wouldn't be thinking substitution because you don't have any variable with a 1 in front of it. So if you try to do substitution, you are going to end up with lots of fractions. If the final answer is going to be a fraction, then it's going to be a fraction whether you do substitution or elimination. I just would like to avoid fractions as long as possible. Okay, so our first choice is to decide, are we going to make the x's opposites or are we going to make the y's opposites?
X's are already opposites.
Okay, so the x is already one's positive, one's negative. We just need to make them the same number, like -8, +8, something like that. So does anybody see what you could multiply the top equation by? Keeping in mind, if you're not sure what you want to multiply by, think of 2 and 3 and try to find a number that they both divide into. 12, and eating smaller? 6. So the goal is going to be to get a 6 and a -6. What could we multiply the top equation by?
3.
So we can multiply by 3, and that's going to be distributed. And what could we multiply the bottom by?
2.
2. And that's also going to be distributed. When I distribute 3 to the top, can someone tell me my new equation? 6x plus 9y equals how much? 15. And how about when I distribute 2? What's my bottom equation?
-6x plus 10y, which equals 42.
Which equals 42. And now, since we have those, we have x with a +6, one with a -6. When we add them up, they cancel out. What's 9y plus 10y?
19.
And 15 plus 42?
57.
57. So we're just adding our columns up. In order to add these columns up, one thing I should have mentioned first is the x's have to be lined up, the y's, and then the numbers. In this case, they already were. Everything was lined up. Okay. Last step, to get y by itself. Divide each side by 19. That's gone. And what do we get for y? 3. Okay, any question how we got 3 for y? Now, this time, since we didn't do substitution, we don't have a nice formula that already says x equals. We just have to take this and plug it back in. We can choose top or bottom equation. Top? Okay. So we're going to take y equals 3, and we're going to fill it back in right there. So it's going to give me 2x plus 3 times 3 equals 5. Okay. I just changed the y to a 3. That's all. All right. So 2x, 3 times 3 gives me 9. Okay, next up.
Subtract 9 from both sides.
Subtract 9 from both sides.
-4.
Gives me -4.
Divided by 2.
and divide by 2. And what does that give me?
Negative 2.
-2. There you go. So y equals 3, x equals -2. And was that a quadratic?
No.
No. So that we don't have to worry about a second x and our second y. There's only one x, one y. Okay. Any questions on that? Okay, so we haven't got into the 3 variable yet. We're just kind of doing the 2 to practice a little bit. Now, when you are solving what we just did, okay, that's called a linear system. If you were to draw this on the calculator, that's a line. And if you were to draw that, that's a line. What would happen at the coordinate -2, 3?
They would cross paths.
That's where the lines would cross. So that's one thing that can happen when you draw 2 lines. They can cross once. What's something else that can happen?
They get never touched.
Right? You could have parallel lines, so they never touch, which would mean what?
There's no solution.
That's a no solution. There's one more thing that can happen.
The other lines could be on top of each other, so they are real numbers.
Right. So we can get the one solution, no solution, or infinite solutions. Okay, one solution looks like that. No solution looks like that. And infinite solutions looks like that. Now, we're not actually sketching, but I think if you think of it as a sketch, it helps you to visualize the 3 things that can happen. So let's try to solve this one, just like we did the last one. Let's use elimination. But this time I don't think you're going to have to multiply both equations, just one. Let's pick a letter first. What letter do we want to try to get rid of?
X.
Okay, X and Y. Those are the
I
options.
choose X.
All right, we're going to go with X then.
Okay.
All right. So
Did you say X?
No,
if we want to get rid of the X's, we need the numbers to be opposites.
You with me? You with me, right?
What could we do to make those X's opposites?
Multiply the top by 3.
Multiply the top by 3. Okay, so we're trying to make the X's opposites. So we're going to multiply the top by 3. That's going to become, when I distribute the 3, what will it become?
6x minus 9y.
Equals 15. And what are we multiplying bottom by?
Nothing.
Nothing. We're not going to change that. So negative 6x plus 9y equals 10. And now add your columns up. What's 6x and negative 6x? That's gone. Negative 9y plus 9y? That's gone. Well, we got to put something on that side. So what can I put over here?
0.
0. So 0 equals
25.
25. So when all your letters cancel, you're done. But what does that mean? 0 equals 25.
No solution.
That's no solution. So you have to know when you get a statement that is not true, it means there is no solution to the problem. And if you were to draw these 2 lines, how would they look?
Don't touch each other.
They would what? They would be parallel, yeah. If you've got y by itself, they would have the same slope, but the y-intercepts would be different.
It's no solution, so they never touch.
Yeah, no
So
solution.
they're parallel.
Any question why it's a no solution?
A parallel equals no solution.
Right, because the solution is where they cross and parallel doesn't cross. Yep. All right, let's try this one. Now, you could do substitution, because I do see a letter that we could get by itself, because it has a 1 in front of it. But since we're doing elimination, we'll just stick with that one more time. Okay. What letter do we want to try to make cancel this time? Okay, so we'll focus on X. If something happens to y, then that's the way it goes. But what could we multiply the top by?
2.
2. So multiply the top by 2. And the bottom, we're not going to change it. Okay, what does the top equation become?
2x plus 6y equals -4.
Equals -4. And the bottom?
-2x plus 6y equals 4.
It just stays the same.
So just a trick question.
Okay. When we add up the x column, what happens?
It's 0.
It's gone. The y column?
Gone.
It's gone. And -4 plus 4?
0.
It's gone.
One solution.
So now all the letters are gone. We're done.
It's all real numbers.
That's a true statement.
So infinite.
'Cause it's an
There's an infinite amount of solutions, all real numbers. Everyone understand the difference between those two things? What's the difference between saying there's an infinite amount of solutions and all real numbers?
Infinite means real and non-real numbers.
Infinite is like also like imaginary numbers as well.
That's what we just said.
Well, they're answering different questions, right? This is a how many question. This is a what question. How many solutions are there? Infinitely many. What are the solutions? All real numbers. So the difference is you're describing how many solutions there are versus what the solutions are. Okay, that's the difference.
So all real numbers would be like any number could be the solution.
It's always-
Yes, all reals is the way you would describe what numbers are the solution to the problem. And you're saying all real numbers. How many numbers are there? Infinite. There's infinitely many solutions.
Okay.
So it just depends on what they're asking.
Yeah, if I asked you how many solutions are there to this problem, you would not write all reals. How many is infinite. What are the solutions? All reals. Okay, so any question on that one? All right, so I think we're good with 2 variable. Now we're going to step it up to 3 variable. Now, when you go up 1 variable, you might think, well, if you had, like, say a 2 variable problem and a 4 variable problem, you might think, oh, well, 4 variables, that's twice as many variables. It's going to be twice as many steps. No, it's a lot more than that. When you go from a 2 variable to 4 variable, it's almost like it squares the number of steps, right? It's a lot more steps. So just going up 1 variable, it ends up being a lot more steps. And we won't be doing 4 variable by hand. Okay, we're gonna do 3 variable by hand. So I'll put the steps down, and then we'll try to go through them. So now you're gonna have a lot of choices. You're gonna have 3 equations. You're gonna pick a variable to eliminate in 2 of them. So you could eliminate, say, x in equations 1 and 2. You could eliminate x in equations 2 and 3. Or you could eliminate x in 1 and 3. And then you could make all those same choices for y. So you're going to have 9 options for the first step. Chances are, 1 out of those 9 options is going to result in a nicer pathway to solve the problem. All right, so let me see. I might reword that. Okay, I'm going to reword that a little bit. So we're going to pick a variable to eliminate in 2 of the equations. Pick, and this is the key. Once you pick the variable, you can't change it. Pick the same variable and eliminate it in 2 different. It has to be different than what you did in step 1, otherwise you're going to repeat step 1. Okay? Pick the same variable and eliminate it in 2 different equations.
What if the equations would be the same as the first one?
Yeah, one of the equations has to overlap, but let's say you pick equations 1 and 2 first. Well, don't pick 1 and 2
Do
here.
like 2 and 3 or
2 and 3 or 1 and 3, yeah, you gotta pick a different pair. So pick the same variable and eliminate it in 2 different equations.
Wait, is this a elimination with 3 variables or 3 equations?
So one equation will, it's like it will overlap. You'll use it twice.
No.
Once you've done this, you will now have two new equations, one from the first step, one from the second step. Two new equations with 2 variables each. We now will have turned the problem into one we know how to do. We'll have taken it from 3 variables down to 2 variables. So you're going to take the 2 new equations that you have and solve that. And then from there, we basically repeat everything we've done with 2 variables. Okay, so that's the general steps. The just thing is, there's a lot more choices. Okay, so first step, you should always make sure of, if it's not done, x's are in a column, y's are in a column, z's, and then the constants are on the other side. I think most problems I give you are already going to be lined up that way, but if it's not, we'll make sure it's lined up. Okay, so we'll try to do this one, and then I have one more, and that's it. Now, a hint as to what variable should you try to eliminate. I look for a variable that has a 1 in front of it. If you don't have one with a 1, it could be harder to do. Or -1. You could do -1. 1's a little easier. Anybody see a variable with a 1 in front of it?
Z or X.
Yeah, the x in which equation?
The third
The third equation, yes. So I would say, because this one has a 1 in front of it, I would eliminate the x. Which equation do you want to use? Well, that's up to us. We have to choose 2. Definitely choose the one that has a 1 in it. Okay, so let's call this equation 3, equation 2, and equation 1. So we want to use 3, but what other equation do we want to use with 3?
1.
We're going to use 1. Okay, so we're going to eliminate x in 1 and 3. So first thing I'm going to do is I'll just copy them down. 2x plus 3y minus z equals -1. And x plus 4y minus 3z equals -8. And the goal is to eliminate the x. Don't worry about what happens to y and z. All right. Which equation would we have to multiply if we want to make the x's cancel? We're only going to have to do one of them.
The second equation.
Yep. And what would you multiply the second one by?
-2.
Yep, -2. And we're going to distribute that out just like that. What's going to happen to the top one?
It's going to stay the same.
It's going to stay exactly the same. 2x plus 3y minus z equals -1. And what's going to happen in the bottom one?
-2x.
2x
8y
minus
plus
8y
6z equals 16.
plus 6z equals 16. Okay. And now, add them up, and that's going to give me one of my new equations. 2x minus 2x, that's gone. What about 3y minus 8y? Negative 5y. Negative 1z plus 6z. Plus 5z. And negative 1 plus 16. 15. Now, normally at that step we're done, but there is something that happened here. Every one of these numbers is a multiple of what? 5. So if we want to make this equation even simpler, we can divide everything by 5. Negative y plus z equals 3. You do not have to do that step, but it will make things a little easier. And I'm going to call that equation 4. So that's one of my new equations. Any question how we got there? Okay, now, do it again. We need another equation that just has a y and a z in it, but we can't use equations 1 and 3. You have to pick some other combination besides 1 and 3. So we do have to eliminate x. And what two equations do we want to use besides 1 and 3?
2 and 3.
Yep, we can do 2 and 3. You definitely want to use 3. 3 is a good one because it has a 1 in it. Okay. All right, so that was our first step. This is our second step. First thing is I'm just going to copy them in. So 2 and 3. 3x minus 2y plus 2z. And as you copy it, double check it. Because if you just copy one number wrong, well, the whole thing's wrong. All right, 3x minus 2y plus 2z. And x plus 4y minus 3z equals negative 8. And what letter are we eliminating? X, that's why we wrote it down right up there. Which equation do we have to multiply to make that happen? Bottom. Yeah. What could we multiply the bottom by? Negative 3. What's going to happen to the top equation?
Stays the same.
Stays the same. So 3x minus 2y plus 2z equals 15. And bottom equation, when you distribute the negative 3, can someone tell me what you got?
Negative 3x minus 9y and then plus 9z.
So negative 3x
Minus 12y
minus 12y
plus 9z
plus 9z
equals 24.
equals 24.
So minus 9y.
That says 24. I ran out of space. Okay, add them up. What's going to cancel? X's are gone. What's negative 2y minus 12y?
Negative 14y.
Negative 14y. What's 2z plus 9z?
11z.
11z. And what's 15 plus 24?
39.
39. There you go. That is equation 5. So even though we don't have any answers to the problem yet, in terms of the amount of work, we're more than halfway done all the work. Okay, so now you've done this and you've done that. Now you have two equations with two variables. Equations 4 and 5. They each have two variables. Now we're going to solve that problem. And that's going to give us the y, and then it'll give us the z. Just kind of separating the steps. At this point, I have no choice what I want to work with. I do want to work with equations 4 and 5. I don't know what letter I want to eliminate yet, so I left it blank. So we have negative y plus z equals 3. And negative 14y plus 11z equals 39. Okay, so what letter do we want to try to eliminate there? Z? Okay. So we're going to eliminate z in equations 4 and 5. Which equation are we going to have to multiply?
4.
The equation 4, yeah, the top one. And what are you going to have to multiply it by?
Negative 11.
Negative 11. Okay. What happens to the bottom?
Stays the same.
Stays the same. I just copy over the one that stays the same. And what do you get when you multiply the top by negative 11?
11y plus 11z equals 33.
Minus 11z equals what?
33. Negative 33.
Negative 33. Add them up.
Yeah, shut up.
Okay, z's are gone. What's 11y minus 14y?
Negative 3y.
Negative 3y. And what's negative 33
Look at me with
plus 39?
6.
6. Okay. Now we're down to one equation with one variable. We can get the answer to that one. How do you get y by itself?
negative 3.
By each side by negative 3. That's gone. And our first answer,
Y equals negative 2.
y equals negative 2. Now, from here, we're going to substitute back in. I guess I can add that. So now you substitute back in to get all your other answers. Okay, I would get z next, and I would use either equation 4 or 5. Which one do we want to use? 4. 4 I think is simpler. Negative y plus z equals 3. And what did we just get for y?
Negative 2.
So fill in negative 2. What's negative negative 2? 2 plus z equals 3. And we got z. So once you get your first answer, the rest of them come pretty fast. We got y, we got z. What's the last thing we need?
X.
X. To find x, could you use equations 4 or 5? No, you eliminated x. You have to go back to the original. Which one do you think would be the easiest to find x?
3.
I would pick 3 because this already has a 1 in front of it. Okay? X plus 4y minus 3z. 4y minus 3z equals negative 8. Oh, that looks awful. Making it worse. So x plus 4y minus 3z equals negative 8. X we don't know. What did we get for y?
Negative 2.
So fill in your negative 2 right there. What did we get for z?
1.
Fill that in right there. And what's 4 times negative 2?
Negative 8.
Negative 3 times 1?
Negative 3.
Negative 3. What's negative 8 minus 3?
Negative 11.
Negative 11. Move the 11 to the right side, and you get x equals 3. And there you go. So x is 3, y is negative 2, and z is 1. So if we kind of zoom out and look at it, that's the amount of steps to solve a 3-variable system. If you compare that to a 2-variable, well, those were special cases, so they were really short. But that's the amount of work to solve a 2-variable. That's the amount of work for a 3-variable. So the number of steps goes way up. It's not really harder steps, it's just more of the same steps. Any question on that one?
Is that the exact way you should do it, like eliminate 1 and 2 and then go to 11, sorry, 1 and 3 and then go to 2 and 3?
No, these can change. So as far as kind of the template, if you were looking at it, it would look kind of like this. Eliminate a variable in 2 of the equations. Which 2? Depends on the problem. And then whatever variable you eliminated here, it has to be the same one there. But these 2 numbers have to be different than the 2 up above. They can't be the same 2.
Repeat what you just said?
What's that?
Repeat what you just said?
So these 2 numbers here have to be different than the 2 numbers there.
So,
Can't use the same equations again.
oh, so as long as they're not the same, not the same 2 numbers, so I can use the same, like, let's say 1 and 5, I can do like 2 and 5?
Well, you're only going to have up to 3.
Well, 3, I mean, like,
1 and 3 and 2 and 3.
yeah, that's what.
Yeah. Or you could do 1 and 2 and 1 and 3, or 1 and, yeah.
Just not the same combination.
Not the same combination.
Okay.
Yep. Once you do that, you're going to get equations 4 and 5. And then what letter you choose to eliminate in 4 and 5, again, it's, you can pick either letter that's in the problem. Yeah. Now, if you look at all the work there, a lot of what we wrote down in that problem was what kind of symbols. We wrote down a lot of variables, okay? If we didn't write any of the variables in that problem, okay, just look at this part alone right there. 1, 2, 3, 4, 5, 6, and equal signs, 7, 8. If we could eliminate writing all the variables and all the equal signs, that would be half, maybe more than half, of what we had to write down. So when we start to use a matrix, instead of writing down variables and equal signs, I can turn this entire thing into this. What I just wrote right there represents what's up above. And it was a lot less writing. So tomorrow, we're going to transition to writing things as a matrix. The steps are going to be pretty similar. The advantage is it just takes up less space. Okay, it's less writing. Well, I guess depending on how big you write, it could take up the same amount of space. But it's less symbols and letters you have to write down. Okay, but tomorrow, that's what we'll look at. Okay, so for tonight, it's 1 through 19 odd. So just all odd questions. Okay, and just a reminder, tomorrow 10-2, Wednesday 11.1, test on Thursday.